I met Ryan when I came across his extensive audio reactive nodes in Comfy UI. And so as an open source developer and applied researcher, his contribution spans communities like Comfy UI and Banadoko, and now Stream Diffusion. He recently implemented IP adapters and multiple control nets for Stream Diffusion, which enables image prompting in real-time video models, which is quite powerful. So he's going to be here and talk to us about his journey there. So take it away, Ryan.
Hi, everyone. I'm Ryan, and my presentation won't load. So we're gonna do it like this. So thank you, Eric, for the introduction, and thanks for everyone else who's spoken so far. It's been great to hear from the people that are foundational to this stuff, and also great to hear about these things from all sorts of different perspectives. So I'm an engineer at LivePeer working on Daydream, and I'm going to go over a few things here. I'm going to talk to you about the changes that we made to Stream Diffusion, which fundamentally was just adding more modes of control. And I'll talk about why we approached the problem in the way that we did, and go over it. So give examples of the individual things that we've added, and then talk about what's next. Try it again. Nice. Let's go. All right. Thank you. Okay. All right. So the reason that we added a bunch of stuff to Stream Diffusion, and this is because builders and artists and open source developers and people building products, they all want more control. More knobs is better. If you give artists more knobs, more craftsmanship will show through in the final product. Just look at what these guys are doing here. You give people building products more knobs, they can solve a wider variety of problems. Open source developers, love to enhance knobs, so give them more to do that with. And I know this not only from just observing people in the community, but also because I fit all of these personas. I'm an engineer at LivePeer. I'm a Comfy ecosystem contributor. I'm a musician and an artist. And my introduction to Gen AI was building a video product. So I know firsthand that the more knobs, literally, the better. It's just much more fun. So I'm going to talk briefly about some of the stuff that I did in Comfy UI, which is inherently not real time. I call it the batch paradigm, but it will sort of set the stage for why we chose to do what we did and how we did it. So, Eric mentioned I built these nodes. I built a bunch of nodes for Comfy UI, and I didn't really add any knobs, but I multiplied the knobs that already existed. So we've got right here. Speaking to them, is that better? All right. So here in the top left, we've got audio controlling live portrait. That's audio controlling 2.1 via the pose conditioning. And then this is the proximity of these two particles controlling the depth map for animate diff. So these are some of the examples of ways that you can turn knobs. There's a huge number of them. So the fundamental knobs that I was turning in Comfy UI are LoRa's IP adapters and control nets. Does anybody here not know what any of those three things are? Okay, so LoRa's they're like small add-on weights to a model that make it cheap and easy to change the whole style. You can apply a whole style or concept. You could think of taking Stable Diffusion and then applying an anime LoRa to it, and then everything that comes out of it will be anime. IP adapter. IP literally stands for image prompt, so you can use an image as a prompt, and the output will assume the sort of style of that reference image. And then control nets are additional neural networks that they accept conditioning like depth maps, poses, whatever, and can influence the output from the primary model. Let's see if these videos work. So here's some examples of things that you can make by turning these knobs. There is audio, but it's not working. So you'll just have to imagine. Here's another one. Okay. So this is by combining LoRa's IP adapters and control nets in various ways. And this is not real time. So what we wanted to do was try to bring some of this control to the real time space. So we did that by sort of enhancing stream diffusion by adding more knobs and SDXL. So we added IP adapters, multiple control nets, LoRa's, all the standard stream parameters, pipeline hooks, and then config. So I'm going to I'll show examples of each of these things. Let's go. All right, sweet. So this is, I'll be showing some stuff with this vibe-coded dev tool that co-evolved as we added these things to stream diffusion. So you can see I'm using this style image of a cardboard box, the Amazon guy. And you can't probably read it here, but the prompt is simply cardboard man. So I want to really illustrate here how much the IP adapter is actually lifting for us. So as I turn the strength of the IP adapter down, cardboard man, the prompt, just does not cut it. It doesn't make me a cardboard man at all. So the IP adapter is doing basically all of it. Really, really powerful stuff that we knew immediately we should add to stream diffusion. So let me get back to my slides here. So that's standard IP adapter with adjustable strength in real time. So what was non-trivial about doing this was making sure that we could still accelerate the model, because it's sort of at odds with the concept of TensorRT. So it seems simple in retrospect, but at the time it was challenging. We baked the IP adapter into the UNet and ended up with full-speed real-time visual conditioning. So what you saw there was me just adjusting the strength at runtime. But there are other knobs, like weight types. So the gentleman who wrapped IP adapters for Comfy UI, through experimentation, found that you can just target specific blocks and get specific results. So there's so-called linear weight type. This is an example of the style, the so-called style transfer weight type. If the video will load, I'll show you. Bummer. Sorry about that. Anyways, with this style transfer weight type, you can't really see it here, but we have a network error. Okay, so the style image is a Studio Ghibli image, and it makes the video Studio Ghibli. I promise. Moving on. Yeah, let's give this a shot. Thank you for your patience here. Going to my phone. Let's give it a shot. Okay, so that was IP adapter, standard IP adapter. There are other types of IP adapters like IP Adapter Plus, which we also support. This is yet another known as Face ID. So just like with the cardboard box one, you can see the prompt. The prompt here is Elsa from Frozen. And it does not look like Elsa from Frozen, really. until we add this IP adapter Face ID. So you'd get a similar result with a regular IP adapter, but this one is just works better and more specifically with the face. So this is Stable Diffusion 1.5, and it gives a pretty good result. It's also supported with SDXL. We added control nets, so folks in the community already had individual control nets running, but some of the best examples that I've seen in the batch paradigm are using many control nets in various combinations. So we added control net conditioning inputs to the surface of the TensorRT engines, such that any number and any combination of control nets can be used in conjunction. It does slow it down quite a bit. So for additional acceleration or additional speed, we accelerated each individual control net model as well. So you end up with like a collection of TensorRT engines all working together. And then all the conditioning pre-processing for these is all done in parallel for the Daydream backend. So I talked about IP adapters, control nets. Now I'll just briefly talk about LoRa's here. Remember, a LoRa allows you to apply a style or a concept to the entirety of the output. So we added dynamic and composable LoRa management, allowing for some pretty cool stuff. Let's see if this will play. So it all can be combined. So here's LoRa combined with IP adapter, and you can just get some really interesting stuff. These demos aren't meant to be. They're meant to be sort of, explanatory, not actual art pieces. Check these out if you want real pieces. So we added these style LoRa's, which work with TensorRT so long as they're trained for the text encoder. But more importantly, we added additional performance LoRa's. So we added SDXL Turbo support. Turbo is fast enough to support real time. But just like with stream diffusion, raw stream diffusion, it ships with the LCM LoRa. So that allows you to use any given SD 1.5 model and speed it up. We did the same thing with SD Turbo. So we added LoRa's like Hyper and Turbo so that you can use any given SDXL model and just get much better results than you can get with the raw SDXL Turbo model. So I talked about IP adapters, control nets, and LoRa's, and the way that we added all of those was through these pipeline hooks. So stream diffusion has like some key point. Input image gets encoded into the latent space. You might remember this from earlier. It gets diffused, and then it gets decoded out of the latent space. So we added some hooks into this process at key points that allow all of those things that we added to be composable dynamically. Let's see if this will play. Nice. Okay. So here we're using a latent pre-processing feedback loop. So it's subtle with this low resolution here, but the flickering. Pay attention to the flickering in the background. This is like an ultra poor man's V2V. So thank you, Jeff, if you're still here. But you can do cool things like this. The whole pipeline becomes composable. So I show a latent preprocessor and also an image post-processor where we upscale the output with real ESR GAN. And this is what we did first, the same thing that Lyle did, .simulate did. We exposed all of the parameters of stream diffusion so that you can update them in real time, including prompt and seed blending from our boy back there. So one thing that we also did that is I think is pretty cool is dynamic resolution and dynamic t-index list length for the engines. So, originally, you need a different engine for each resolution. So if you're building a product where you want to have both horizontal and vertical, that will require 2 engines. If you want a low-quality one with 2 steps and a high-quality one with 4, that's another 2, and it's multiplicative. So you end up exploding the number of engines that you need to store to power your product. So since we made these 2 things dynamic, it reduces that number by quite a bit. So that's the gist of all the stuff that we've added to Stream Diffusion V1, and it's really exciting to see people start using it. It's really awesome. So what's next? Hopefully we can just do it again, but with the newer stuff that you saw people talk about earlier today. For instance, here's some early experimentation with prompt blending with Stream Diffusion V2 in scope. It's very early. Come on, dude. Here we go. So here I can't even read the prompt, but if I remember, it's we're blending a sailboat on the water with a dog in the grass. So you can get some really interesting stuff, some really disturbing stuff too. But I'm excited to see where we go with this. We're going to start like we did with Stream Diffusion and do these fundamentals, and then hopefully get into some of the more hardcore stuff a little bit later. So I'm really excited to see where it goes. Thanks again, everybody, and thank you for having me.